In this video, we are going to take a look at graphing exponential and logarithmic functions, a review of this graphing from your Algebra 2 course, but also a good refresher of the two graphs. And we're going to utilize the calculator a little bit to help us with the critical points. So I filled in the first page for you. I'll just take you through a couple key pieces of information to compare. The exponential functions, so the a to the x and e to the x, both have horizontal asymptotes. And in fact, why don't we add that word in next to this, horizontal, at y equals 0. And the log graphs, log base a of x, and also the natural log, or ln of x, are both vertical asymptotes. And then what I filled in for you is just the picture of the graph, which is important, and that those asymptotes that are on there, and also the table of points that are going to be our main focus when we are doing the graphing. So you might want to take a minute to pause and get all of that filled in. Same thing with the bottom set. The bottom two, even though they pretty much are the same, are the special bases. So E is the natural base. In your calculator, it's approximately 2.72. E is similar to pi, where it's a number that's occurring naturally, but also used in our financial world as well. And then the natural logarithm is a log base E. So you'll see that in the second graph on there. The tables follow the same rules, except 1 over E and E can be calculated to decimals that make it easier to use the transformations when graphing. That's how we choose to do it. All right, so I'm going to move past this first page. If you have to rewind or pause it to get all that information down, you can. So let's see, how are you going to use this with our graphing? A couple things to remember with graphing is our transformations. So we're going to list those out, and I'll remind you how we could use those with the critical points, but then our focus here is really going to be the calculator. So with this function, we have the 2 out in front would be a vertical stretch by a factor of 2. And then we have in the exponent plus 3 and outside of the exponent minus 5. Those are our 2 translating. Translate left 3 and down 5. I'm going to quickly go through what I would do if I were going to do those transformations. I would start with my table that's in that format because of my base 3. Back when we did other types of graphing, we would multiply the y column by 2 or do a mapping. 2/3, 2 and 6. And then I would subtract 3 from this column, subtract 5 from that column to get my final table. I did go through that kind of quickly. I just want to remind you of how we could do this by hand. And then take you into the calculator to find these points quickly. Right, so if we were using the transformations, we would do the stretching and then the translating in our second set. Before we go to the calculator and go look up that information, there's key information that's I feel is really important for you to know about these particular graphs. The first thing is the down 5, or the subtracting 5 here, is giving you our horizontal asymptote. Notice I put HA here. That's the horizontal asymptote. So we'll go down to 1, 2, 3, 4, 5, and put our dashed line there. So it's looking like the graph is going to show up above that line because there's more space there, but we'll see that when we get the points. Now let's pretend that I did not do all of the transformations. I'm going to get rid of that. But the key transformation there is that down 5 because that asymptote line is going to move down to that spot. Let's go to our calculator. Let's plug in our y equals 2 times 3 to the x plus 3 minus 5. Now I could graph it, but it's a lot easier to do these graphs from the table. So I'll hit second graph, go to my table, and I have a lot of good information in here. I can scroll and notice the numbers get big kind of quickly, which is normal in an exponential function. But I want to scroll back to get some of those smaller points that I can plot. And what we're looking for is when you hit that first decimal on this particular situation, those are the 3 points that I want you to plot there. So the -4, -4.33, we'll go back for a minute, -3, -3, and -2, 1. And the reason I'm picking these points is because they're surrounding normally the y-axis, they're not too far away. Even when you do the transformations, they will fit nicely on your graph. I think I went a little far there. 1, 2, 3. Go, and then -2 and 1. And then when you connect these, it flattens as it gets close to the asymptote and it pulls away from the asymptote very quickly. So I'm not going to ask you to do labeling here. I do have that in my posted notes, so I can do that. But the key is getting some good points that fit on the graph, understanding where the asymptote goes, and then getting that general shape of your curve. Now we can identify some of the other information. The domain for this graph is always going to be -∞ to infinity. For our exponentials, it will be the same thing down here. So that's an automatic fill-in because that doesn't change. What does change now is our range. The graph is starting at -5. Notice I'm using parentheses here because of the asymptote line. It gets really, really, really close to -5, but it doesn't touch -5. So you want to put the -5 there with a parentheses because it's not included. Or your other option would be y is greater than -5. Notice the number in the range and the horizontal asymptote match up. That's very important. And then the y-intercept we can also get from our table. If we go down and look for where the 0 is in x, and record that y value that goes with it. So 0, 49 would be our y-intercept. So your focus for these is being able to identify the transformations and then getting the correct horizontal asymptote range, and using your calculator to help you get some good points on there so you can get that general curve plotted. So let's do one more of those. We'll wrap up this video, and then we'll do a second video for the log graphs. So this one we have the negative is reflect over the x-axis. So we'll expect to see this one underneath the asymptote line. We have a vertical stretch by a factor of 3. And then we have our 2 translating. We have right 1 and up 4. So we'll expect to see our points kind of going in that direction and probably be in that first quadrant area. And we'll look for those in our calculator. Before we do that, though, we can identify some key elements from the graph. The +4 and the up 4. That's giving us our horizontal asymptote at y equals 4. So let's put that dashed line on there. And then it's also telling us our graph is either going to be y is greater than or less than 4. So if you go with that option, we just have to figure out what symbol to fill in between. And then let's go to our calculator. So this is a little different because it's E. Most of the values in the calculator will be decimals. Now you can do E in two places. I can hit second division, which then means I need to put an exponent there. Or I can hit second ln. ln is between the 7 and the 4. Either one works. That one brings up the exponent right away. Once you have that typed in, second graph. Now, instead of searching for the decimals, since they all are, I'm actually searching for the integer number here. And I can see that gives me some good points there. 2.896. It happens to also be our y-intercept. We might as well fill that in right now. You know what? I don't want to be doing this in red because the red is really supposed to be highlighting the asymptote and the range. Sorry for overwriting that. What else do we have? 1, 1, and 2, negative 4.2. And just to get some good points on there, 2.86, 1, 1, and so the graph is getting close this direction and pulling away the other direction. So we can see the graph is going underneath. Once we have those points plotted, that would be less than 4, or if you want to do negative infinity, comma 4, that is also a good option. Just make sure you use the less than sign, and if you use the other one, you're doing the parentheses. All right, so that'll wrap up the exponential graphing and review of that, and we'll look at the log graphing in a second video.